Hi students, we are discussing kinematics. So kinematics we discussed one-dimensional motion we are discussing. In one-dimensional motion so far we discussed there are different types of motions we are discussing. First one we discussed uniform motion. Under that we did some problems. Next one is we are discussing uniform accelerated motion. In that we are discussed horizontal motion and vertical motion. In vertical motion we have freely falling body and vertically projected body. So far these are the things we discussed. Okay. And the next one is we are going to discuss this variable acceleration. So a body moves with variable acceleration. So variable acceleration. Variable acceleration, variable accelerated motion or variable acceleration motion. Okay. What is variable accelerated motion? How we can define uniform circular motion? What is a uniform circular motion? We discussed the acceleration of a particle remains the same both in magnitude and direction. Such a type of motion is called uniform accelerated motion. What is variable accelerated motion? If acceleration changes with the time, acceleration changes with the time, then we can call it as variable acceleration. So what is variable accelerated motion? Acceleration of a particle changes either in magnitude or direction, either in magnitude or direction or both. Such a type of motion is called variable acceleration motion. So in variable accelerated motion, if acceleration is given as a function of a time t, so suppose the displacement is given. So displacement is given as a function of a t. Then you need velocity. You will get a function of t. What we have to do? Do differentiation. Do differentiation. Okay? X position is given. We want velocity. So do differentiation. Velocity is given as a function of a t. You want acceleration. Do differentiation. Okay. Suppose acceleration is a function of a t. You want a velocity. Velocity is a function of a given t. You want a displacement. Do integration. So this differentiation, this integration is a reverse process of differentiation. So if you want velocity as a x is given, x is position. What is x? Position. X is position. What is v? Velocity. What is a? Acceleration. So position is given as a function of a t. You want velocity. Do differentiation. Velocity is a function of a time t. You want acceleration. Do differentiation. Reverse process. Acceleration is a function of a time t. We know that. We want velocity. Then do integration. If you want a specific values, do integration with the proper limits. Velocity is a function of a t. You want position where it is. So do integration. Okay? Based on this, we are going to do a problem. Okay? Take this example. The acceleration example. Acceleration of a particle moving along x-axis, x direction is given by a equation given by a is equal to 3 minus 2t meter second to the power minus 2. At the instance t is equal to 0 and t is equal to 6 seconds, it occupies same position. It occupies the same position. Find A. Find the initial velocity. Question mark. B. What will be the velocity? At t is equal to 2 seconds. So this is the question. Okay? So this is the problem. Acceleration of a particle moving along x-axis is given by this expression. So solution. Okay. Acceleration is given by the expression a is equal to 3 minus 2t. It is a function of t. Okay. So it is a variable acceleration. What is that? It is example for variable acceleration. How you said this one? Because the time is a variable, independent variable. As time goes on, this time changes, acceleration is also changes. So this is an example for variable acceleration. So we want at the instant t is equal to 0, t is equal to 6, it occupies the same position. So find its initial velocity. So first you find acceleration is given, you find velocity. So velocity we can write it as a can be written as dv by dt. So from definition of acceleration we have a is equal to dv by dt. That is 3 minus 2t. So you bring this one, this side. So dv is equal to what we have? 3 minus 2t into dt. Okay, just I bring this dt this side. This is called integral form. Acceleration is given, we want velocity. So what we have to do? Integration. So now I am going to do integration. So I will write here. Okay, on integrating. So what you will get? dv, integral dv is equal to 3 minus 2t into dt. Initial velocity, we want initial velocity. That means at instant t is equal to 0. So initial velocity I take it as u, and velocity is a function of v. I write it as v. So uv 3 minus 2 dt. So you write first velocity is a function of t. Integral dv v. First you write function. This is integral. You apply distributive. Integral dv is v 3 minus 3 dt. Integral dt. So I am applying distributive. Minus 2 into integral t dt. So I am applying distribution here. Just I open the brackets. So 3 integral dt. So integral dt is t minus 2 into integral t dt. So we have t square by 2. So this 2 get cancelled. So here I am using the formula integral x to the power n dx is equal to x to the power n plus 1 by n plus 1. I am using this formula. Integral dt is t, integral t dt. So here power is 1. 1 plus 1 2 by 2. So this 2 get cancelled. So I got velocity as a function of t. 3 t minus 2 get cancelled. You will get a t square. T square. So you put t is equal to 0. So what you will get? Initial velocity. So substitute this velocity is also a variable. So we got velocity is a function of t. Okay. This 2 get cancelled, you will get a t square. So I will take this space. Okay. See. So I got velocity is a function of t, and it occupies the same position at the instant t is equal to 0 and t is equal to 6. I want a position. So velocity is a function of t is we have. I want a position. So v can be written as, so we have v is equal to 3t square, 3t minus t square. Okay. So this velocity is a function of t. Velocity definition is dx by dt. Rate of change of position, displacement is velocity. So dx by dt is 3t minus t square. Okay. So again do integration. dx is equal to 3t minus t square into dt. Okay. So you integrate this one. on integrating this one, integral dx is equal to integral 3t minus t square dt. Next I am writing here, okay, this one, integral dx is x is equal to t dt, that is 3, you apply distributive, 3 into integral t dt minus integral t square dt so that is x. So we have x is equal to integral dx, this is integral dx, I applied distributive here, 3 dt t dt minus t square, okay, so that is 3 t dt, you apply this formula, x to the power n dx, x to the power n plus 1, t plus 1, t square by 2, so 2 is a constant, t square by 2 minus integral t square dt, so that is t cube by 3, so that is integral dx is x. So we have x is a position of t, we got, okay. So here on integrating with the limits, you substitute the limits, initial velocity we want, let it be v naught, velocity is a function of v. So initial velocity we don't know, you integrate with the proper limits, so 0 to t, so you substitute the limits here, integral dv is v, substitute the limits v naught to v, okay. So upper limit minus lower limit, 0 to t, so integral v is v minus, after integration you substitute the limits, upper limit minus lower limit, v minus v naught, what is v naught? Initial velocity, okay. So v is equal to, you bring this minus v naught this side, so it will become plus v naught plus 3t minus t square. So this v is a function of velocity, we got v is equal to v naught plus 3t minus t square, you call it as equation 1, where here v naught is initial velocity. Again I will take this one, so v is equal to v naught plus 3t minus t square, so integral dx, so I will write this expression once again, v naught plus 3t minus t square, integral dx, so this is integral dx is equal to v naught plus 3t minus t square into dt. On integrating we have integral dx x naught, so we have integral dx, again you have to, here you write v naught also, v naught plus 3t minus t square into dt, okay. This function we are going to do integration, okay. Integral x, integral dx, you substitute with the proper limits here once again, so x naught to x, So here t 0 to t once again. So here just I am writing this one here. So integral dx, limits are x naught to x. X naught is initial position, x is the function of x position. So integral dx is x. You substitute the limits. X, limits are x naught to x, v naught to dt. You apply distributive. v naught integral dt plus distributive 3 into integral t dt minus distributive t square dt. So limits are 0 to t, x naught to x. So integral dx is x. After integration you substitute the limits. Upper limit minus lower limit. X minus x naught is equal to v naught integral dt t plus integral t dt t square by 2, that is 3t square by 2 minus t square dt, that is t cube by 3, limits 0 to t. So I am substituting the limits also. Okay, minus, so t cube minus 0, you will get t cube only. So I substituted. So I got x is equal to x naught, you bring this one, x naught plus v naught to t plus 3 by 2 t square minus t cube by 3. So we got x is a position, you call it as equation 2. Okay, so I got position x is equal to x naught plus v naught to t plus 3 by 2 t square minus t cube by 3. So we have at intervals, so now I want its initial velocity. We want initial velocity and velocity at t is equal to 2 seconds. I will rub this one. So we got here, now see, we got this is the first expression, velocity, second expression, position. Okay, so what I did here, integration. Now we have at t is equal to 0, at t is equal to 0, at t is equal to 0, then x is, what is x? X naught plus t is equal to, this becomes 0, so you will get 0. Okay, this here t you substitute 0, you will get x is equal to 0 at t is equal to. Okay, otherwise I will rub this one also. So I will write here at t is equal to 0, then x is equal to, you substitute t is equal to 0, you substitute x is equal to x naught. At t is equal to 6 seconds, isn't it? At the position we have what is the given? The given expression is at t and at the instances t is equal to 0 and 6 seconds, the particle will occupy the same position. X is equal to t, you substitute x is equal to x naught plus v naught to t t you substitute 6 plus 3 by 2 6 6 square 36 plus t cube. What you will get? 6 cube. 6 cube is 36 into 6 by 3. So this is minus. Okay. So that is x is equal to x naught plus 6 v naught plus this will become 2 36 18 18 into 3 54. Here it is 3 3 2's 36 into 2 72. So minus 72 54. So how much you got? 2 6 plus 2 8 6 1 minus 18. So this one will becomes minus 18. So these two are equal. So what is given? Given x of 0 is equal to x of 6. This is x of 0. This is x of 6. Both are equal. Then you equate these two. So what you will get? X naught is equal to x naught plus 6 v naught minus 18. Okay. So that is x naught get cancelled. So you will write 6 v naught is equal to 18. So what is v naught? Then v naught is equal to 3 meter per second. So I got initial velocity v naught is equal to 3 meter second inverse. So for the first question, what is the first question? Find its initial velocity. So we got initial velocity as, for the first question, answer is 3 meter second inverse. Then what is the next question? Next question is will be the velocity at t is equal to 2 seconds. So we have velocity at t is equal to 2 seconds. So you substitute in this expression. v2 is equal to, what is v? v is equal to v naught plus 3t minus t square. Velocity at t is equal to 2 seconds. v naught, what is v naught? 3 plus 2 into 3 into 2, t is 2 minus t square, 2 square 4, that is 3 plus 6 minus 4, that is 9 minus 4 5 meter second inverse. This is velocity at 2 seconds. Okay. So what are the questions left? So these are the questions. Velocity at 2 seconds we got is 5 meter second inverse. Okay. Clear this sum? So what is the given sum? Acceleration is given, is a function of t. We want initial velocity. The given information is at 2 instances of time. T is equal to 0, t is equal to 6 seconds. It occupies the same position. That information is given to find initial velocity. Okay. For that what I did? First step I find velocity. Acceleration is given, I find velocity. How? I integrate. Second step, I got velocity. Then I obtained position. How I got velocity? I did position by integration. Once again, second step. Once I got, okay. So then I did After getting the position, you equated at 2 instances of time t is equal to 0, 6 seconds. I equated, then I got initial velocity. After that is the answer for the first one. Second one is we want velocity at 2 seconds. So what I did in the velocity expression, I substituted t is equal to 2 seconds. Then I got velocity as 5 meters per second. This we did. Okay, next model. Okay, next model. Suppose, so this is the problem we did, velocity, acceleration is a function of at. The next model is, if acceleration, second model, acceleration as function of position. Acceleration is a function of position. So what is the definition of acceleration? A is equal to dv by dt. This we can also be written as, you multiply with dx, divide with dx, multiply with dx. This dx get cancelled. So you will get dv by dt. That is, this dx by dt can be written as velocity, v into dv by dx. So this is acceleration. So acceleration is equal to velocity into dv by dx. This equation we are using frequently to solve the problems when acceleration is a function of position. You take this example. Take this example. Acceleration of a particle along x-axis is defined by the law A is equal to minus 4x, where A is acceleration in meter second to the power minus 2, x is position in meters. At the instant t is equal to 0, particle passes the origin with a velocity 2 meter second inverse, moving in positive x direction. Find number 1, A. Its position, find its position V, find its velocity, find its velocity V as function of its position, as function of its position coordinates. This is the first sum. Second one, B, find its position, X as function of t, time, t. C, find maximum, find the maximum distance it can go away from origin, So these are the problems we have. So first one is acceleration of a particle along the x-axis defined by the law. So A is equal to minus 4x. So this is acceleration, A, solution. So acceleration is minus 4x. It is a function of x. At the instant t is equal to 0, the particle passes origin with velocity moving positive x direction. So find its velocity. So velocity is a function of x. So this acceleration is a variable. The first thing. So it is the problem based on variable acceleration. So you have to do integration or differentiation. So acceleration is defined as dv by, you have to write in terms of position x. So we can write it as v into dv by dx is equal to minus 4x. So this is, I have written A is equal to v into dv by dx minus 4x. So the next one is, I will write here, A is equal to, so v dv, just I am cross multiply, minus 4x dx. So this is integral form. So on integrating, so integral dvx is equal to integral x dx. Just I cross multiply that one and limits. So velocity is, at the instant t is equal to 0, it passes origin with velocity 2. So initial velocity is 2 and velocity as a function of t, v, let it be v. So origin is x is equal to 0, then its position is x. So these are the limits. 0 to x. Integral v dv by using x to the power n is equal to x to the power n plus 1 by n plus 1. By using that formula, we will get v square by 2, limits 2 to v, minus 4 x dx. So we will get x square by 2, limits 0 to x. That is, after integration, you substitute the limits. V square by 2 lower limit is 2 square. So 2 square is 4 is equal to I substituted limits here, upper limit minus lower limit. Instead of v, you substitute 2 square, 4, minus 4 by 2, you will get to 2. 4 by 2 is minus 2 into x square minus 0 x square. So that is x square. So v square is equal to, so v is equal to, here is 2 into 2, 4. 4 x square minus, you bring this minus this side, it will become plus 4. Okay, you take 4 as common, this is minus x square. So here minus 4, bring this side, it will become plus 4. 2 into 2 minus 4x square. Okay, this is velocity. Okay, so you take common 4. So v is equal to, we got v is equal to, so I will write here, acceleration of a particle as a function of defined by the law. Okay, I will rub this one. So we got v is equal to, I will write here, v is equal to 4, you take it as common, you get 1 minus x square. This is v square. I want v, under root. So 2 into under root 1 minus x square. So I got, this is velocity, you call it as equation 1. So find its velocity as a function of its position. So this is the answer. So for the first question, answer is this one. V is equal to 2 into square root of 1 minus x square. Next, find its position x as a function of a time t. For the second one, we have velocity and we want its position as a function of t we want. So v can be written as, I will write instead of v, I will write dx by dt, 2 into square root of 1 minus x square. Okay, so the next step I am writing here. So a is equal to, so I will rub this one also. So I need space. So first one is also over. Okay, so we are doing second one. So we want its position. So dx is equal to 2 into square root of 1 minus x square, it dt this side. So dt, that is on integrating, you bring this x this side, square root of 1 minus x square is equal to 2 dt. Okay, so I want to position x as a function of a time t. So on integrating, so this expression, what you will get, integral dx by square root of 1 minus x square dx is equal to 2 integral dt. The limits are origin 0 to x, integral dt 0 to t. That is on integrating, integral dx by 1 minus x square. So you remember this formula. Here I am giving a new formula in integration, later you will get in mathematics. That is integral dx by 1 minus x square, it is sine inverse x by 1. Sine inverse x by 1 is 1. So sine inverse x. Okay, x by 1. Here you will get, this is 1 square is 1. It is in the form of integral dx a square minus x square. So the answer is sine inverse x by a. Here a is 1. So sine inverse x. So after integrating this one, I will write here. So this is the second one. Position as a function of t. So after integrating this one, we have sine inverse x. 2 into integral dt is t. That is, x is equal to integral sine inverse x, then x is equal to sine 2t. So we have this. This is the answer for second one. What is that? Find the position as a function of time t. Okay. So what is the second question here? Find the position as a function of t. So for that answer is x is equal to 2. Next, what is the c? Find the maximum distance it can go away from origin. So you check away from origin. So it is a harmonic function. Position is a harmonic function, sine. So its position varies harmonically like a sine function. So it in a regular intervals of time, okay, with an angular frequency 2. Now we want maximum distance it can go away from origin. At t is equal to 0, x of 0 is 0 when t is equal to 0. That means it is at origin. Okay. Maximum distance, maximum value of sine function is 1. So x is equal to 1. Since maximum value of sine 2t is equal to 1. So what is the maximum distance it go from away from origin? If it is x is equal to 0 here, maximum distance how much it can go away from origin? Up to 1 meter. So this is x is equal to 1 meter. And again it will return back. Okay. Then again it will oscillates like this. So it is a harmonic function. So this is the answer for second answer. So this is answer. Next model. Okay. Clear this model? In the second model, what I did, acceleration is given a position of x in the second model. So I have written, first step is acceleration I define a is equal to v into dv by dx as minus 4x. Then I integrated. First step, I got velocity as a function of position. In the second step, I want position. So I know velocity. So again I integrated. So I got position. So these are the two steps involved in this problem. Clear? Take this. Next model. Okay. Acceleration is a function of velocity. Acceleration is a function of velocity. next model. Okay, this is model number 3. Model number 3. So acceleration is a function of velocity. Example, acceleration for this example. Acceleration of a particle moving along x-axis, moving along x-axis according to the law, according to the law, A is equal to minus 2v, where A is acceleration in meter second to the power minus 2, velocity and v in meter second inverse at the instant t is equal to 0. Okay, the particle passes the origin, pass the origin with the velocity of 2 meter second inverse, moving in the positive x direction, Find A, find its velocity, v as function of t. B, find its position, as function of t. Third one, find its velocity, as function of its position, position coordinates, D, find maximum distance, it can go away from origin, this is D. E, so next, last question, will it reach the above mentioned maximum distance? Will it reach above mentioned maximum distance, okay? So this is the problem we have. Okay, now how we can solve this one? See how we can solve this one. Let us try to solve this one. Let us solve this one. Now, acceleration is, what is the given law? Acceleration is equal to minus 2 into v. So, acceleration can be written as velocity as a function of t. So, we will write it as a. We want velocity as a function of position. First, a is equal to dv by dt, function of time. Velocity is a function of time. So I define acceleration as dv by dt minus 2 into dv. So I want velocity, dv by v is equal to minus 2 dt. This is integral form. Just I reshuffle. The next one is on integrating. So what you will get, integral dv by v is equal to minus 2 into integral dt. Integral dv by v. So we have the formula integral dx by x is equal to log x ln x to the base e. Okay. So I am using this formula, integral dx by x ln x. Ln means log to the base e. So ln x. So integral dv by e is, I will using this one, ln x. Ln v. Ln v is equal to minus 2 integral dt t. Integral dt is v. So you have to substitute the limits. As the particle moving along the x-axis according to the law. At the instant t is equal to 0, the particle passes the origin with velocity 2. So here limits is 2 to v. Time is 0. At the instant t is equal to 0, the particle passes the origin. t0 t. So integral, after integration you substitute the limits. Lower limit is 2, upper limit is v. So ln v. So I will write here ln v. Upper limit is v. Upper limit minus lower limit. ln v log v minus log 2. So log a by b. Log a minus log b we can written as log a by b. So I am using that expression. So log, that is ln v by 2. V by 2 log a by b is equal to minus 2 t. So limits t minus 0 minus 2. So ln you bring this side, v is equal to, so when you are removing this logarithm, here you have to get exponential, e to the power minus 2t. This is v by 2. I want v. So v is equal to 2 e to the power minus 2t. You call it as equation 1. So this is answer for A. Velocity as a function of t. So I got v is equal to 2 e to the power minus 2t. So this is the answer for first question. Okay. Next one. Second one is, so I am using this space. I need this space. Okay. So this is the last problem today. I want to finish this one. Okay. First one is over. Second one, find its position as a function of t. So once we got velocity, I want its position as a function of t. So again you integrate. So we have v is equal to 2 e to the power minus 2t. I am writing that expression, equation 1. So v means velocity. Velocity can be defined as dx by dt is equal to 2 e to the power minus 2t. So dx is equal to 2 e to the power minus 2t dt. Then on integrating, once again you integrate. On integrating, integral dx, limits origin 0 to x, 2 e to the power minus 2t dt, limits are 0 to t. So the first one I am erasing this one. First one we got the answer. Second one, so integral dx is x. Substitute the limits, x minus 0, x 2 integral e to the power x. Integral e to the power x is e to the power x only. So that is e to the power minus 2t, I am writing as it is. After integration, you differentiate this one and write in the denominator, that is minus 2. T with respect to t you will get 1. So this 2 get cancelled. So you will get, I am writing here. So x is equal to 2 get cancelled minus e to the power minus 2t. So you call it as equation 2. So this is as, so here x, you have to take the limits 0 to x, limits are 0 to t. T. So here integral dt. Okay, you substitute with the limits here 0 to t. You substitute the limits. After integration, you substitute the limits 0 to t. T after substituting this one, upper limit minus lower limit, that is minus lower limit. What is lower limit? E to the power 0. Upper limit is t, e to the power 0, minus 0. What is e to the power 0? You will get e to the power minus e to the power 0. What is e to the power 0? You will get 1. So this is x is equal to 1 minus of minus plus 1 minus e to the power minus 2t. So you will get, this one is the answer for the second one, B. So this is the answer for B. What is that? X is equal to 1 minus e to the power minus 2t. Okay, next one. So we got second one, find its position as a function of t. So we got this. Next one is, find its velocity as a function of its position coordinates. Find its velocity as a function of position coordinates. Velocity as a function of position coordinates. So we have to write here, acceleration is equal to, instead of v, we have to write v into dv by dx. Okay, so that is, instead of A here, so I will write here velocity as a function of position. What is we have? We have velocity is equal to, we have what is given expression? Given expression is A is equal to minus 2 into x. This is the given law. Okay, from this given law, A is equal to minus 2b. This is given law. The motion of this particle follows this law. This is given. So instead of A, I am writing dv by v into dv by dx is equal to minus 2v. That is v dv. I will cancel this 2 and 2. So dv is equal to minus 2 dx on integrating. So next step is on integrating. Integral dv, initial velocity to final velocity v minus 2 integral dx. Initial position origin x. So integral dv is v. Limits upper limit minus lower limit is equal to minus 2 into integral dx x. Upper limit x minus 0 x. So v is equal to 2 minus 2, bring this side, plus 2 minus 2x. That is v is equal to 2 of 1 minus x. So this is the answer for C. That is third equation I take. What is that? Question: velocity is a function of x. Velocity is a function of position. Velocity is a function of position coordinates. So this is the answer for third question. So we got third one. Third one is over. The next one is fourth one. What is fourth one? Find maximum distance it can go away from origin. Maximum distance it can go away from origin. So you take this one. T is equal to 0. X of 0. What you will get? 1 minus e to the power 0. E to the power 0 is 1. So 1 meter. X, maximum distance it can go away from origin. T 0. You put T is infinitive. E to the power infinitive. E to the power minus infinitive. So what you will get? 1 by infinitive. 1 by infinitive is 0. So this factor becomes 0. So x of infinitive is again infinitive. So maximum distance it can go is, maximum distance the particle can go away from origin is answer 1 meter. So this is the answer for fourth equation. Answer for fourth one. That is 1 meter. Okay. Next question. Will it reach above mentioned maximum distance? Yeah. Maximum suggested maximum distance is, will it reach above mentioned maximum distance? As t tends to infinity, x is 1 meter. So as time goes on infinity, it reaches 1 meter. So is it possible? No. So will it reach the above mentioned maximum distance? For that answer is, what your answer? So answer, no. Will it reach above mentioned above distance? No, never. So answer is never it attains 1 meter. So these are the answers for this question. Okay. So So in this problem, we have discussed this is the model of acceleration is a function of position. Okay. Acceleration is a function of velocity. So we discussed in today's class, acceleration is a function of variable accelerations, today's lesson. So in that I discussed three. First one is acceleration is a function of t, acceleration is a function of position, third one acceleration is position of velocity. All these belongs to, this is one dimensional motion. So these are the few examples for acceleration, one dimensional motion. Today I am going to close this one. Thank you.